Think about the last time you felt truly invincible, like you could hold on to everything that mattered. Did you ever wonder how much of that world, those moments, even the stars above you, have already quietly slipped away? Scientists tell us that galaxies vanish without a trace, entire planets just disappear, and even the light from our own past is racing away from us. Now, what if I told you that this same silent vanishing is happening right inside your own life? If everything around us is slowly fading, then what is the one thing that actually lasts forever? You look up at the night sky and assume you are seeing the universe as it is right now, in this very moment. But that is one of the most profound illusions your senses can create, because every star you see is a ghost. The light from the nearest star to Earth left its surface about 4 years ago. By the time it reaches your eyes, your life has already moved on, and so has that star. Now hold that thought and multiply it. According to observations from NASA's James Webb Space Telescope in 2022, the faintest, most distant galaxies we can detect are sending us light that has been traveling for an astonishing 13.4 billion years. That light began its journey before our planet even existed, before the sun had finished gathering its mass, and in the vast, silent stretch of time since, those stars could have burned out, collapsed, or vanished entirely. When you finally catch a glimpse of them, you are not looking at a vibrant, living sky. You are reading a postcard from a graveyard. This is not just a poetic idea, it is a physical fact that astronomers confront every single night. Take the famous case of supernova of 1987A, which offers a perfect, almost eerie demonstration of how seeing actually means remembering. In 1987, an astronomer named Ian Shelton was working at the Las Campanas Observatory in Chile, and on a routine check of the sky, he spotted something strange with his naked eye. A bright point of light where none had been before. That was a massive star exploding, a supernova, and it became the first one visible without a telescope in nearly 4 centuries. But here is the part that sends a chill down your spine. That star was located 168,000 light-years away, which means the explosion had happened 168,000 years ago. When Shelton looked up and wrote down his observation, he was watching a death that had occurred long before modern humans had even invented language. The star was gone for thousands of generations, yet its final farewell was only then arriving on Earth, just as the light happened to meet a young astronomer's curious gaze. He was not witnessing an event. He was uncovering a relic, and the universe was simply delivering a message that had been in transit for millennia. So, if you extend that logic from a single star to the entire observable sky, you begin to understand why scientists describe the heavens as a museum of ancient echoes. There is a galaxy called GN11, first identified by the Hubble Space Telescope in 2016, and it holds the record for being one of the farthest objects we have ever confirmed. Its light has traveled roughly 13.4 billion years to reach our instruments, meaning we are seeing it as it looked when the universe was just a few 100 million years old. Yet here is the punchline that reshapes your entire perspective. That galaxy as it exists today has almost certainly changed beyond recognition. The light we see is a fossil, a snapshot from infancy, while the actual galaxy has already evolved, rearranged, and perhaps even faded into something entirely different. We are scanning the sky for a present that has long since slipped away, because the cosmos refuses to show us its current face. What you see when you look up is not a real-time map but a stack of ancient photographs, each one exposing the universe at a different stage of its past, and none of them showing the world as it is happening right now. That realization hits harder when you let it sink into your bones. Your eyes are not windows, they are time machines, and they travel back further than any machine ever built by human hands. Every star that twinkles in your view is a messenger carrying a report that might be decades or billions of years old, and the messenger you see might already be dead. Just think about that for a second. You are looking at a sky full of objects that have already vanished, and your brain keeps telling you they are all alive and shining at this very moment. The distance between you and the stars is so vast that the universe has become a collection of stories, each one delayed by the speed of light, and you are reading them all at once. If you could somehow see the sky without that delay, most of what you love about it would disappear, because the stars you admire would be missing, and the shapes you recognize would break apart. That means the night sky is not the reality of the cosmos, it is a memory, a beautifully illuminated archive of everything that used to be there. But this is where the wonder turns into a larger question that pulls you toward the next mystery. If light itself can fade, if the very signal that carries the universe to your eyes can arrive only after the source has long since died, then what about the things that are built to last? What if there are objects out there that do not simply dim or vanish, but exist in a way that outlives the light they once emitted? Because if the sky is already a graveyard of distant fires, then the real story lies beyond the flames, in the remnants that persist after the glow is gone. The stars themselves are not the whole tale. They are just chapters, and some of them end with a violent collapse that creates something far more terrifying and permanent than anything you have ever imagined. So, before you decide that a twinkling star is a sign of safety and continuity, ask yourself what happens when that star takes its final breath. Because that is when the universe shows you what disappearing really means. A star doesn't simply stop shining one night like a light bulb burning out. It performs a slow, agonizing dance with gravity that can last for millions of years, and we are only privileged enough to watch the very end of it. In the year 1054, Chinese astronomers recorded a guest star so bright that it was visible in broad daylight for weeks, a sudden blaze where nothing had been before. Today, at that exact spot in the sky, we see the Crab Nebula, a tangled web of gas and dust that is the only remaining evidence of a supernova that erased its parent star entirely. Looking at it now is like visiting a cemetery and reading a tombstone that says, "No one is home anymore." The universe has a quiet, steady rhythm of farewells that we barely notice, because most of them happen too far away and too faintly to catch our eye. According to the European Space Agency, about 3,000 stars die every year in the observable universe, which sounds like a terrifyingly high number until you realize how small that is against 2 trillion galaxies. Yet even that statistic feels distant, so let's bring it home. In our own Milky Way, a galaxy that holds somewhere between 100 and 400 billion stars, the ESA Gaia mission tells us that only 1 or 2 stars run out of fuel each year. We live in a cosmic graveyard where every century or so, a single sun collapses somewhere in our neighborhood, and we never even hear it happen. What is even stranger is that our sun, the very thing that gave us daylight this morning, is already participating in this slow vanishing act. NASA calculated that every single second, the sun loses about 4 million tons of its mass, converted into pure energy by nuclear fusion in its core. That sounds like a catastrophic leak, but here is the twist that puts everything in perspective. The sun is barely a teenager in stellar terms, and it will happily keep burning through about half of its remaining fuel before it finally grows tired. It is not the star that is disappearing right now. It is the time it has left, and that is a much more frightening currency because it cannot be renewed. So, the next time you look at the night sky and see 1,000 pinpricks of light, remember that most of those fires have already been extinguished. You are reading an obituary, not a live broadcast, and the stars you admire have been dead for centuries, their light merely taking a long, slow journey to reach your eyes. What remains after they are gone is not the star itself, but the memory of it, stretched across space and encoded in the light that will keep traveling for billions of years after the source is nothing but dust. And if that light ever reaches another planet, some other conscious being will look up and believe they are seeing a live star, when in truth they are only seeing a ghost. That is the heartbreaking beauty of it all. The universe is full of things that have already vanished, yet they keep glowing in the memories of distant observers. A star can die in a brilliant supernova that outshines an entire galaxy, or it can fade so slowly that no one notices for billions of years, but either way, the moment it stops, it is gone forever. No encore, no sequel, no second act, just the cold, quiet aftermath of a celestial farewell. And now, the question that should unsettle you. If these giants of light and fire cannot hold on to their existence, what happens to the products they leave behind, those hungry shadows that swallow everything around them? Let's be honest, a black hole is the most terrifying idea physics has ever produced. We talk about stars burning out, but a black hole isn't just a dead star. It's a place where the universe itself seems to tear open, swallowing light and matter into a silence that lasts forever. You are looking at the ultimate destination for anything that gets too close, a region where the normal rules we cling to simply stop applying. To grasp this, consider the monster hiding at the center of our own galaxy, a silent giant called Sagittarius A. It holds the mass of about 4 million suns crushed into a point so small it defies imagination, a gravitational trap so deep that not even light can climb back out. This isn't a distant theory, it's our galactic heartbeat, a beast that has been feeding for billions of years. But for a long time, that's all it was to us, an invisible inference, a mathematical ghost haunting the equations. Then, in April 2019, everything changed when the Event Horizon Telescope unveiled the first direct image of the unseeable, the supermassive black hole at the heart of galaxy M87. That blurry orange ring wasn't just a picture, it was the first raw visual proof of these vanishing objects, showing a shadow against a glowing disk of superheated gas, matter spiraling into a pit from which there are absolutely no return. This was the moment we saw a truly disappearing thing with our own eyes. A confirmation that the mathematics were pointing at something real and terrifying. What struck researchers about M87 was not just its existence but its appetite. Studies from 2021 suggest this colossal beast is spinning at nearly the speed of light, a cosmic whirlpool that is voraciously consuming its surrounding material. Yet even this gluttony has a limit, as scientists calculate that within the next 500 years, MH7 will have depleted its immediate food supply, meaning its dazzling display of destruction will grow quiet, hiding its power in the... It's as if the universe's most dramatic act of disappearance will eventually just fade into stillness, becoming a silent void waiting for its next accidental meal. So, what happens when these hungry giants have consumed everything they can reach? Here is the twist that makes you feel the coldness of deep space. Even the black hole itself is not permanent, as a concept from Stephen Hawking in 1974 suggests they slowly leak energy and mass over unimaginable timescales. This means that these ultimate symbols of permanence will eventually evaporate, a single black hole with the mass of our Sun taking 1,067 years to vanish completely, leaving behind only a faint echo of radiation. It is a timeline so long it makes the age of our universe seem like a single heartbeat. Yet it reveals that in this cosmos, the only true constant is that nothing, absolutely nothing, is built to last forever. You can feel it before you can explain it. Your own hand resting on this table, solid, warm, undeniably. But zoom in far enough and that certainty starts to crumble. The atoms that make up your skin are mostly empty space, and the protons at their core are supposedly immortal building blocks. Physicists at CERN, however, have spent years calculating a different fate, suggesting that even the proton, the very anchor of your physical being, carries an expiration date of around 1,034 years. In theory, it will eventually decay, dissolving the very foundation of your form. It sounds like a distant, abstract horror. Yet the universe is already demonstrating the principle on a far more urgent timescale. A free neutron, the kind that exists outside a stable atomic nucleus, doesn't wait around for cosmic eons. The particle data group measures its half-life at a fleeting 10.3 minutes before it breaks apart into a proton, an electron, and a neutrino. In the 14 billion years since the universe began, nearly all of these free-floating particles have vanished completely, so the pieces of reality are already unraveling. The only question is one of timing. But something even stranger is slipping through you right now, without warning and without trace. Labs researchers have confirmed that about 100 billion neutrinos are passing through your body every single second. These are particles with almost no mass, interacting with virtually nothing, and they depart as silently as they arrive, leaving absolutely no sign they were ever there. Think about that. A stream of cosmic messengers is traversing your flesh as you read this sentence, and you are completely ignorant of their passage. They don't just pass through you, they pass through planets, through stars, through the entire Earth, as if it were made of transparent glass. It creates a deeply unsettling feeling, doesn't it? An invisible world, moving through the most solid things you know, leaving nothing behind. But here is the true punchline. The principle that rules over all of this slow disintegration. The second law of thermodynamics is the only law of physics that isn't just a model. It's a one-way ticket. Entropy, the universe's level of chaos, can only increase. It never ever decreases. This means every ordered structure you've ever loved, every star, every planet, every memory held in your neurons, is slowly, inexorably sliding towards a state of maximum disorder. The very rise of complexity from the Big Bang was a temporary local miracle against a universal tide of unraveling. Your body, this room, the air you're breathing, all of it is a fleeting pattern in the noise before the pattern dissolves. So if the fundamental stuff of your own existence is not permanent, then what is? The stars themselves? The planets? If the neutrons have faded and the protons are on borrowed time, what is the fabric of the world we can reach out and touch? Picture 2 trillion galaxies scattered across the observable universe, each one holding hundreds of billions of stars. Then imagine that we can only ever see 43% of those galaxies, a number from the University of Michigan in 2023 that makes you feel suddenly, profoundly small. This is the beginning of a quiet realization. The universe isn't just vast, it's fading in real time. In late 2022, the James Webb Space Telescope captured an image of a galaxy called JACE GSC CT0, a faint red speck that existed just 300 million years after the Big Bang. Its light traveled for 13.4 billion years to reach our detectors across almost all of cosmic history. But here's the haunting part. That galaxy, as it was when the light left it, is gone. It has either changed beyond recognition or already vanished into some distant state we can no longer observe. What we saw wasn't a thing, it was a ghost of a thing. The force behind this quiet vanishing act is expansion. Space itself is stretching gently but relentlessly, pulling most galaxies away from us at speeds we cannot outrun. Einstein's general relativity predicted this, but even he didn't expect the universe to accelerate. The galaxies beyond our local group are now receding so quickly that in about 100 billion years, they'll slip past a cosmic horizon. They won't explode, they won't shatter, they will simply become invisible, their light stretched so thin it no longer exists. 100 billion years sounds like forever, but the process has already started. We are living inside the moment before the curtain falls. Some galaxies, though, don't just drift away. They die slowly, like a candle starving for oxygen. Take IC 1101, the largest galaxy ever discovered, lying some 1.04 billion light-years from us. It's a monster, spanning millions of light-years across, yet it's fading. Its star formation has slowed to a trickle, the brilliant blue bursts of new suns replaced by the long red glow of aging ones. NASA's data from the IPAC archive shows it slowly dimming, and it won't stop until every last star inside it goes dark. The galaxy is still there, but its life force is waning. In a universe of 2 trillion galaxies, this is the pattern. Most are already quiet, most are already fading, and most will one day be unreachable. So the question you need to sit with is this: how much of what we believe exists is actually just waiting to disappear? The answer is almost everything. We look up at a sky full of light and think we're seeing a living universe, but most of what we see has already been gone for eons. And every second that passes, more of it slips away. The stars, the galaxies, the very fabric of space between them, all of it is moving toward a state where it won't be visible to anyone, anywhere, ever again. And the strangest part is, we're the only ones who ever got to watch it happen. Envision the universe as a balloon inflating at an ever-increasing rate. Everything on its surface is being pushed away from everything else, and this invisible force, this relentless expansion, is what causes distant galaxies to slip beyond our reach forever. Now imagine a heavy object resting on a torch sheet in a pitch-dark room. You cannot see the object, but you can feel the gravity of its presence and observe how it warps everything around it. That is our situation with dark matter. Here is the mind-bending part that should leave you feeling a profound sense of awe and confusion. According to CERN in 2021, roughly 95% of the universe is composed of things we cannot directly see or comprehend. We are essentially blind to the universe we live in, and this invisible majority is not just passively there. It is actively orchestrating the great cosmic vanishing act we have been exploring. The Planck collaboration data from 2018 breaks it down with brutal clarity. Dark energy makes up 68.3% of the universe, dark matter accounts for 26.8%, and the ordinary matter that makes up every star, planet, and human being you have ever known constitutes a measly 4.9%. We are a rounding error in our own cosmos, clinging to a sliver of reality. But what exactly is this phantom substance that dominates our reality? CERN clarifies that dark matter has never been directly observed. Its existence is only inferred from the way galaxies rotate, as if held together by an invisible gravitational glue. It is a permanent reminder that in this universe, not seeing something absolutely does not mean it is not there. This unseen mass shapes the very architecture of the cosmos, yet it remains a ghost to our senses. And the true terror, or perhaps the most fascinating twist, comes from the work at Stanford. Their research in 2020 suggests that our universe is not just expanding, it is expanding faster than our standard models can predict by a margin of 5 to 10%. This accelerated growth, driven by the mysterious dark energy, is the mechanism that is speeding up the disappearance of everything beyond our local neighborhood. It is the hidden hand pushing the galaxies away from us, accelerating the moment when the last light from the farthest stars will simply fade into nothing. So, who is really in control of this grand cosmic narrative? It is not the stars we see, but the invisible force that is tearing them away from us, making them vanish before our very eyes. Ashes drift through a cooling universe, and one day, the last ember of the last star will simply fade. This is the quiet ending scientists call the Big Freeze. And recent NASA simulations from 2023 suggest it will take an almost incomprehensible amount of time to unfold. The stars won't go out in a dramatic flash. They will dim slowly, one by one, over a period of roughly 100 trillion years until the cosmos is left in darkness. Right now, the cosmic microwave background, that faint echo from the beginning of everything, sits at a temperature of just 2.725 Kelvin, a figure recognized with the Nobel Prize in 2006. As the universe keeps expanding, that temperature will creep closer and closer to absolute zero, and with it, the last traces of warmth will slip away forever. Think about the life cycle of a star like our Sun for a moment. It will eventually collapse into a white dwarf, a dense, cooling cinder of what it once was. According to research from Caltech published in Nature in 2020, these stellar remnants will take an astonishing 10 quadrillion years, a 10 followed by 15 zeros, to cool down completely. After that, they'll transform into something called a black dwarf, an object so cold and dark that it becomes effectively invisible, a monument to a star that has vanished from all observation. The universe will be filled with these silent, unseen ghosts, marking the places where brightness and energy used to live. It is a fate that seems to contradict everything we know about the vibrant, chaotic sky we see above us tonight. And then there are the black holes, those devourers of light that we spoke about earlier. They don't get to escape this fate either. Because in 1974, Stephen Hawking proposed a theory in nature that changed how we see them forever. Through what we now call Hawking radiation, every single black hole in existence is slowly leaking its energy, evaporating particle by particle into the void. A black hole with the mass of our Sun would take 10 billion trillion times the age of the universe, roughly 10 with 67 zeros after it, to completely disappear. When that final burst of radiation is released, the most extreme objects in the cosmos will simply cease to be, leaving behind nothing at all. So we have to ask ourselves, if the stars fade and the black holes evaporate, what is left to mark that they ever existed at all? The cosmic microwave background radiation, the very first light ever released, will not provide an answer because it too is destined to thin out into nothingness. As the fabric of space stretches, this ancient relic will cool and dilute until it is utterly undetectable, wiping away the last fossil record of our universe's birth. Every single process, from the nuclear fusion in a star's core to the gravitational pull of a galaxy, is running down like a wound clock, and the end state is a perfectly uniform, silent, and cold equilibrium. I want you to imagine a world without change, without energy, without any kind of event at all, because that is the final destination of this grand expansion. This slow, inevitable march towards stillness is the story that all of creation is writing with its every moment. We are taught to trust our eyes. Seeing is believing, we say, and we carry that assumption like a shield, assuming that anything beyond our vision is simply gone, erased, or non-existent. But the universe has a way of laughing at our common sense. And it turns out that disappearance is often just an illusion, a trick of perspective. Think about it. The moment you flip a light switch, the light from the bulb doesn't just vanish. The photons scatter, bounce off the walls, and travel outward into the cosmos, an infinite echo of a simple action. The past isn't destroyed, it's just radiating away from us at the speed of light, growing fainter but never truly ceasing to exist. For a long time, scientists thought the absolute beginning itself was gone, a single singular moment lost to the void. But in 1965, Arno Penzias and Robert Wilson discovered the cosmic microwave background, a faint hiss of static filling every corner of the sky. That noise, which earned them a Nobel Prize, is the afterglow of the Big Bang, a fossilized whisper from the universe's very first moments, still washing over our planet every single second. The birth of everything isn't a closed book. It's a radio broadcast we can still tune into, a shimmering relic of a beginning we never truly lost. And this principle doesn't just apply to the distant past, because even cosmic corpses can reopen their eyes, and that's exactly what astronomers at Yale University witnessed in 2018 when they studied an obscure galactic core. A black hole at the heart of galaxy SDSS 1350728, silent and dormant for over 20 years, suddenly began to feed, ripping apart nearby matter and blazing with light as if waking from a long, deep sleep. We assume that once something darkens, it stays dark. But this sleeping giant proved that objects we've written off as dead can violently roar back to existence when the conditions are right. And that's a humbling reminder that nothing is ever truly permanent. We have to stop treating "I can't see it" as the same as "it has vanished." The most profound proof of this comes from the very fabric of gravity itself. And the story started in 1967 with a young graduate student named Jocelyn Bell Burnell at Cambridge. She detected a faint, repeating radio signal pulsing with perfect regularity, a signal so precise that she and her colleagues jokingly named it LGM-1, short for Little Green Men, because the only natural explanation seemed to be an alien civilization trying to contact us. It turned out the signal wasn't from extraterrestrials at all. It was a pulsar, the spinning, magnetized corpse of a giant star that had exploded long ago, a dead object that was still screaming its presence into the cosmos. Here was something that should have been gone forever, yet it was announcing its existence with the regularity of a lighthouse. And it was actually the discovery of these cosmic lighthouses that laid the groundwork for one of the most incredible modern detections. On September 14, 2015, scientists at LIGO picked up a signal so faint it was barely a whisper, a ripple that had traveled 1 billion light-years across the universe, carrying an unbelievably powerful message. That ripple was a gravitational wave, the final dying ring of two colliding black holes, a violent event that had concluded long before Earth even had life on it. Yet we could hear its echo, meaning an event that disappeared 1 billion years ago was still making an impact on our detectors here and now. Nothing is lost, it just changes form. We tend to think of the past as something that ends, but everything leaves an imprint. Every explosion, every death, every collision sends an invisible shockwave rippling through space-time that never fully fades away. And the ultimate demonstration of this is the fact that we can recreate the beginning of time itself in a laboratory. At CERN, physicists using the Large Hadron Collider have managed to smash particles together with enough force to create a quark-gluon plasma, the exact state of matter that existed in the first 10,000ths of a billionth of a second after the Big Bang. They are literally resurrecting a state of the universe that we thought had vanished forever, and they can do it in a controlled environment, meaning the gone is never truly gone. It can be resurrected. So the next time you think something has disappeared, remember that the universe is a hoarder, a cosmic archive that keeps every single memory tucked away, waiting for the right moment to reveal itself to us again. The disappearing act was never an ending, just a transition into a different way of being seen. We treat the sky as a permanent fixture, a constant backdrop to our lives. But what if the most fundamental events in cosmic history are also the most invisible, locked away behind a wall of light we can never pierce? We can trace the death of stars, the swallowing of matter by black holes, and the slow drift of galaxies, yet there is one disappearance that dwarfs them all, the complete erasure of everything that came before the Big Bang. Scientists tell us that the Big Bang happened roughly 13.8 billion years ago, a figure from NASA's WMAP mission that marks the absolute beginning of time as we can understand it. The very concept of an ego breaks down before this point. Everything that existed prior, if existed is even the right word, is not just hidden from us. It is fundamentally unknowable, a realm of physics that our minds and instruments have no capacity to access. This is the ultimate vanishing act, where not just an object but an entire reality has been erased from history. What we do have, however, is a ghostly remnant of that cataclysmic birth. In the first 3 minutes following the Big Bang, the universe was a furious, searing cauldron that forged the simplest elements. The ratio of hydrogen to helium in the cosmos today stands at roughly 75% to 25%, a precise fingerprint of that frantic creation event, a ratio that has remained essentially unchanged for billions of years. When you look at the stars, you are looking at the leftover ash of the universe's very first moments of existence. But the scale of this beginning is almost too immense for the mind to hold. Researchers at MIT announced in 2021 that the Big Bang produced an estimated 118 photons. That's a 1 followed by 118 zeros, an unfathomable ocean of light. This staggering number explains the faint background glow that fills our universe, yet these photons, the very messengers of creation, are also invisible to us, having been stretched and cooled into a faint microwave hiss over the eons. Even the story we've constructed about this beginning is not without its deep fractures. Measurements from the Hubble Space Telescope in 2019 put the universe's expansion rate at 74.03 kilometers per second per megaparsec, while data from the Planck satellite calculates a slower 67.4. This discrepancy is a glaring, unresolved problem in modern cosmology, a crack in our understanding that shows how much about the universe's origin and fate still remains hidden from us. The past is not a quiet, settled place. It is a frontier of active and urgent questioning. So how do we face a boundary this absolute? We can see the aftermath, we can measure the elements, and we can count the photons, but the event itself and everything before it is sitting behind a curtain we cannot draw. It is a humbling thought, a stark reminder that for all our telescopes and theories, the first chapter of our cosmic story is and always will be the most profound disappearance of all. We look up at the stars and feel small, but the real disappearing act is happening right beneath our feet, in the soil, in the air, and in the voices of our own species. We have stared at dying suns and evaporating black holes, yet the most intimate proof of cosmic loss is that researchers at MIT discovered in 2022 that over 99.9% of all species that ever existed on Earth are now gone. That is not a tragedy, that is the rule. The universe does not make exceptions for biology, and it certainly does not make them for us. Consider the most famous massacre in our planet's history. 66 million years ago, an asteroid roughly 10 kilometers wide, the size of Mount Everest, slammed into what is now the Yucatan Peninsula. The Chicxulub impact did not just kill the dinosaurs. It erased about 75% of all species on Earth in a geological heartbeat, according to UC Berkeley. Forests collapsed, oceans acidified, and the sky turned to ash. Yet here is the twist that should chill you. That event, as catastrophic as it was, is just one chapter in a book that has been burning for billions of years. Species vanish, ecosystems rebuild, and then they vanish again. The pattern is so consistent that scientists at MIT now call extinction not an anomaly but the default state of life. We are living in a brief, fragile pause between disappearances. But if you want to feel the loss on a scale you can actually touch, do not look at fossils. Listen. The United Nations estimates that every 2 weeks, a language disappears from the face of the Earth. Not a dialect, not a slang, but an entire system of thought, a unique way of naming the world, a repository of songs, jokes, and prayers that will never be spoken again. It is exactly like watching a star blink out of existence, but instead of a supernova, we get silence. When a star dies, its light takes millions of years to reach us, so we see its ghost. When a language dies, the last speaker simply stops talking one day, and the knowledge vanishes without a trace. No telescope can recover it. Now, you might think that some disappearances are temporary, even beneficial. In 2020, the global COVID-19 lockdowns gave the planet a sudden gasp of air. The International Energy Agency recorded a 5.4% drop in human carbon emissions, the largest single-year decline ever measured. Skies cleared over Delhi, dolphins returned to Venice, and for a few months we proved that we could change our behavior overnight. But here is the punchline that hurts. By 2021, emissions surged back to record highs, exceeding even pre-pandemic levels. The disappearance was an illusion, a momentary pause that we immediately reversed. It was not a lesson learned. It was a sneeze in the middle of a hurricane. Think about what this means for your own body. You are made of atoms that have been recycled through countless dead organisms, through dinosaurs, through trees, through microbes that no longer have names. Every breath you take contains nitrogen that once filled the lungs of a creature that has been extinct for 300 million years. You are a walking museum of vanished life, a temporary arrangement of matter that will soon be rearranged again. And yet you still talk about permanence as if it exists. Picture a block of ice melting in a warm glass of water. That is how a black hole evaporates, slowly, atom by atom, over 10 to the 67 years, according to Stephen Hawking's theory. Now picture a star running out of fuel, like an oil lamp sputtering in the dark. That is the big freeze, the ultimate end of every sun in the sky. These cosmic processes are not metaphors for life on Earth. They are the same physical law operating at different scales. The heat death that will end the universe is the same force that ended the dodo, the same force that is erasing a human language every 2 weeks. Entropy is not a villain, it is the only true constant we have. Every single thing you see, every tree, every face, every building, every star, is a temporary pattern in a universe that is fundamentally about loss. We like to believe that what we observe is the whole story, but it is not. It is a tiny, fragile fraction of what once existed. The species that are gone outnumber the living by 1,000 to 1. The languages that once rang through valleys and cities now exist only in the dust of forgotten archives. The stars we see tonight are already dead, their light arriving too late for a final goodbye. So, here is the uncomfortable question that sits at the center of all this. If disappearance is the rule, not the exception, then what makes you think your story, your culture, your language, your name will be any different? You are not an exception. You are a temporary arrangement, a brief flicker of energy in a universe that is constantly cooling down. And that is not a reason for despair. It is a reason to pay attention, to listen to the last speakers, to record the fading stars, to hold every moment a little tighter, because everything you love is already in the process of becoming a memory. Somewhere out there, a force has already screamed its last breath. Not a whisper, not a warning, just a violent, blinding flash that carried more energy than our sun produced in its entire 10 billion year lifetime. And then nothing. The source vanished completely. We saw the flash, we measured its power, but the engine behind it is already gone, a silent ghost drifting in a distant part of the sky. That flash was GRB 22109A, detected by NASA's Fermi satellite in October 2022, the most powerful gamma-ray burst we have ever recorded. It erupted about 2.4 billion light-years away, and for a few seconds it was a cosmic lighthouse, a beacon so bright it briefly outshone entire galaxies. But here's the strange part. After the burst, the source simply turned off. No follow-up signal, no lingering glow, nothing. The object that produced the most energetic explosion in recorded history has seemingly vanished from the universe, leaving behind only a fading afterglow that itself disappeared within days. We are watching a performance where the actors leave the stage before the applause even begins. But it gets even stranger. In March 2008, another burst named GRB 080319b was so intensely bright that if you had been standing outside on a clear night and looked in the right direction, you could have seen it with your naked eye. Think about that for a second. You could have seen an explosion from 7.5 billion light-years away. A distance so vast that the light left its origin before our planet even had complex life on land. And yet, that light still reached your eyes. The burst itself lasted less than a minute. The source again disappeared. We captured its flash, but the object remains invisible to every instrument we point at that region of space today. Now, let me ask you something. You remember TON 618? It is the most massive black hole we have ever found, a true monster with a mass of 66 billion suns. If it sat at the center of our solar system, its event horizon would swallow everything out to the orbit of Neptune. But here is the twist. We have never actually seen it. We know it exists only because of the way its gravity distorts the light of objects around it. The black hole itself emits nothing, reflects nothing, and radiates absolutely zero information about its own structure. It is a ghost, an invisible giant that we are certain is there, because we can watch other things disappear into it. TON 618 is the ultimate proof that something can be undeniably real and completely invisible at the same time. But not all vanishing acts happen far away in the depths of space. Some are happening right here, in our own cosmic backyard, at this very second. Our own atmosphere is bleeding. NASA estimates that Earth loses about 3 kg and helium every single second, stripped away by solar wind and escaping into the void. It is a slow leak, of course, nothing that threatens us in any near future, but it is a one-way door. That gas is never coming back. Indeed, the planet you are standing on is right now lighter than it was when you started reading this sentence. And look up at the moon tonight. It looks permanent, doesn't it? A constant companion hanging there in the night sky just as it has for billions of years. But it is moving away. According to data from NASA's Lunar Reconnaissance Orbiter, the moon drifts about 3.8 centimeters farther from Earth every single year. That is roughly the length of a standard paperclip every year. It sounds tiny, but over deep time the numbers become enormous. A billion years from now, the moon will be so far away that total solar eclipses will be a thing of the past, a memory stored only in ancient rock records. The moon has not disappeared, not yet, but it is slowly walking away from us, an eternal farewell happening at the speed of a growing fingernail. So what exactly stays forever? You see, the universe around us is not a museum of permanent objects. It is more like a river, and we are standing on a rock in the middle of it, watching everything flow past. Stars flare out, black holes hide, atmospheres leak, and moons drift away. And yet, most people will go through an entire lifetime without ever noticing. We walk outside, we see the moon, and we assume it has always been there and always will be. But the truth is, every single moment, this living, breathing cosmos is fading away in quiet, unobservable ways. And that is exactly what we are going to uncover next. Faint light flickers in a remembered room, a warmth that once defined your mornings, a familiar voice now only an echo in the spaces between your thoughts. We chase permanence, anchoring our hearts to people and moments we beg to stay, yet the universe whispers a different truth. We have traced the journey of photons from dying suns, watched galaxies drift beyond the cosmic horizon, and felt the deep, irreversible pull of entropy in our own bones. Nothing we touch, see, or love is built to last. NASA's WMAP data reminds us of this profound scale. The observable universe stretches 93 billion light-years across, yet we can only see 46.5 billion light-years in any direction. Everything beyond that boundary has vanished from our sight forever, not because it ceased to exist, but because the expanding cosmos has carried it beyond the reach of light itself. This is the grand, quiet tragedy of existence. From a proton that might outlive 1 trillion suns to the neutron that decays in 10 lonely minutes, from the black hole that consumes a star to the one that evaporates over an unimaginable span, the equation is always the same. But here is the pivot, the place where despair might turn to wonder. Our story is not just a record of loss, it is a testament to our stubborn refusal to accept silence as the final answer. The Dark Energy Spectroscopic Instrument, the DESI project that began in 2021, is even now mapping 35 million galaxies and 2.4 million quasars. It is a desperate, beautiful attempt to measure the very force pulling everything away, to understand if this accelerated vanishing is a final decree or just a chapter we haven't finished reading. So we return to the question we started with, the one that began this journey through the void. If every star will dim, every galaxy will recede, and every atom will one day scatter, what could possibly be permanent? The answer is not in a thing, but in a direction. The stars will die, but the act of looking up will not. The universe will grow cold, but the warmth of our curiosity will outlast the last ember of a dying sun, because that fire is the one weaker within us that the cosmos cannot take away.